Hi, good evening. This is Dr. Abdul Rahim. Today, we are going to discuss a new topic in the differential equation, that is about the homogeneous differential equations. आज हम differential equations में नए टॉपिक के बारे में डिस्कस करेंगे, वो है homogeneous differential equations. మనం ఇవాళ differential equations లో కొత్త టాపిక్ నేర్చుకుందాము. ఏంటది? homogeneous differential equations. Today we are going to discuss about what is a homogeneous function. Then when do we say that the differential equation is a homogeneous differential equation? Then we are going to discuss about the procedure for solving the homogeneous differential equations, and then we are going to solve the problem, right? So आज हम homogeneous function के बारे में जानकारी करेंगे. उसके बाद homogeneous differential equation किसको कहते हैं, और उसके बाद प्रोसीजर होमोजेनियस डिफरेंशियल इक्वेशन को सॉल्व करने का तरीका, प्रोसीजर के बारे में जानकारी करेंगे, और उसके बाद हम प्रॉब्लम सॉल्व करेंगे. మనం ఇవాళ హోమోజీనియస్ ఫంక్షన్ అంటే ఏంటి, దాని తర్వాత హోమోజీనియస్ డిఫరెన్షియల్ ఈక్వేషన్ దేని అంటాము, దాని తర్వాత హోమోజీనియస్ డిఫరెన్షియల్ ఈక్వేషన్ ని సాల్వ్ చేయడానికి ప్రొసీజర్ తెలుసుకొని దాని తర్వాత ప్రాబ్లమ్ సాల్వ్ చేద్దాం, రైట్? So now let us go to the definition of a homogeneous function. When do you say that the given function of two variables x and y is said to be a homogeneous function? A function f of x comma y is said to be a homogeneous function of degree n if f of lambda x comma lambda y is equals to lambda to the power n into f of x comma y. If the function can be expressed as like this for any non-zero constant lambda, then we say that the function f of x comma y is said to be a homogeneous function of degree n, where lambda is a non-zero constant, right? So f of x comma y को हम कब कहेंगे कि homogeneous function? इस कंडीशन को सेटिस्फाई करना चाहिए. x के बदले में लैम्डा x रखेंगे, y के बदले में लैम्डा y रखेंगे, और सब्स्टिट्यूट करने के बाद अगर हम कोई इस प्रकार का आंसर आता है तो हम फंक्शन f of x comma y को क्या कहेंगे? होमोजेनियस फंक्शन ऑफ डिग्री n कहेंगे, और लैम्डा जो है नॉन जीरो कांस्टेंट है. ఫంక్షన్ ని మనం ఎప్పుడు హోమోజీనియస్ ఫంక్షన్ అంటాము, ఎఫ్ ఆఫ్ ఎక్స్ కమ్మ వై ని హోమోజీనియస్ ఫంక్షన్ ఎప్పుడు అంటామంటే మనం ఎక్స్ బదులు లాంబ్డా ఎక్స్ సబ్స్టిట్యూట్ చేసి వై బదులు లాంబ్డా వై సబ్స్టిట్యూట్ చేయగానే మనకి ఇలా సింప్లిఫై చేస్తే ఇలా రావాలా, సింప్లిఫై చేస్తే ఇలా వస్తే మనకి ఫంక్షన్ ఎఫ్ ఆఫ్ ఎక్స్ కమ్మ వై ని ఏమంటాము? హోమోజీనియస్ ఫంక్షన్ ఆఫ్ డిగ్రీ n అంటాము. సో నౌ లెట్ us see some examples regarding the homogeneous function and a non-homogeneous function. होमोजेनियस फंक्शन का एग्जांपल और नॉन होमोजेनियस फंक्शन का एग्जांपल एक प्रॉब्लम करेंगे, ठीक है? होमोजेनियस फंक्शन देन अंटामो, नॉन होमोजेनियस फंक्शन देन अंटामो एग्जांपल्स చూద్దాం మనం. Let us take the example f1 of x comma y is equals to x square plus y square. So now we have to find out whether this function is a homogeneous function or not. इस फंक्शन को होमोजेनियस, ये फंक्शन जो दिया गया है उस फंक्शन होमोजेनियस है या नहीं, इसके बारे में పతా करना है. మనకి f1 అనేది x, y is equals to x square plus y square ఇచ్చినాడు. ఇది homogeneous కాదా అనేది తెలుసుకోవాలి. So we have to apply the definition. So what we have to do? So you have to substitute instead of x lambda x, instead of y we have to put lambda y in the given function. So then what happens? Instead of x we have to put lambda x square plus instead of y we have to put lambda y square. So now చేసిన తర్వాత expand lambda square x square, सिंप्लीफाई करो इसको, लैम्डा स्क्वायर x स्क्वायर आएगा प्लस प्लस लैम्डा y होल स्क्वायर इज इक्वल्स टू लैम्डा स्क्वायर y स्क्वायर. सो सिंप्लीफाई करने के बाद क्या आएगा हमें? लैम्डा स्क्वायर x स्क्वायर आएगा प्लस लैम्डा स्क्वायर y स्क्वायर आएगा. So now what we have to do? You take the lambda square common. So lambda square is here and lambda square is also here. Take the lambda square as a common factor. So lambda square common factor निकालना है, उसके बाद x square plus y square लिखेंगे. So but x square plus y square क्या है? x square plus y square क्या है? ये f1 of x comma y. So इसके बदले में x square plus y square क्या है? f1 of x comma y. So x square plus y square into f1 of x comma y. So we substitute here. So therefore this is f1 of lambda x comma lambda y is equals to lambda square into f1 of x comma y. So therefore we have expressed in this form. So therefore f1 is a homogeneous function of degree 2. So this condition is satisfied. Therefore the given function is a homogeneous function of degree 2. ठीक है, हमने इसको वेरीफाई किया. तो f1 ऑफ लैम्डा x कमा लैम्डा y कैसा आया, लैम्डा स्क्वायर इंटू f1 ऑफ x कमा y आया। तो इसलिए f1 क्या हो गया, इज ए होमोजेनियस फंक्शन ऑफ डिग्री 2। సో f1 అనేది మనం వెరిఫై చేసినాం, ఏమని హోమోజీనియస్ కాదా అనేది వెరిఫై చేస్తున్నాం. ఎలా చేస్తాము, x బదులు లాంబ్డా x సబ్స్టిట్యూట్ చేస్తాం, y బదులు లాంబ్డా y సబ్స్టిట్యూట్ చేస్తాము. సింప్లిఫై చేస్తే ఏమైంది, లాంబ్డా స్క్వేర్ ఇంటూ f1 ఆఫ్ x కమా y వచ్చింది. సేమ్ ఫంక్షన్ వచ్చింది, లాంబ్డా స్క్వేర్ ఇంటూ సేమ్ ఫంక్షన్ వచ్చింది. కాబట్టి ఈ ఫంక్షన్ అనేది homogeneous function of degree 2, right? So now let us take another example. दूसरा एग्जांपल लेंगे, फिर एग्जांपल తీసుకుందాం. f2 of x comma y is equals to sin x plus cosine y. So now again we have to verify whether it is a homogeneous or not. So same procedure. So instead of x, what we have to do, substitute. x के बदले में lambda x सब्स्टिट्यूट करना है, y के बदले में lambda y सब्स्टिट्यूट करना चाहिए. x बदलू lambda x, y बदलू lambda y सब्स्टिट्यूट చేయాలా ఫంక్షన్ లో. సో sin of instead of x lambda x plus plus cosine cosine instead of y lambda y. So now here in the previous problem we were able to take out lambda square as a common factor. previous problem में हम लोग जो है ना lambda square को common factor निकाला है हमने, is what it was possible निकालने के निकाल सके. लेकिन यहाँ पे जो है ना हम लोग लैम्डा को नहीं निकाल सकते कॉमन फैक्टर, क्योंकि ये लैम्डा जो है ना साइन फंक्शन के अंदर है. మనం ఇక్కడ లాంబ్డా ని కామన్ ఫ్యాక్టర్ గా తీయలేము. ఇక్కడ మనం ప్రీవియస్ ప్రాబ్లం లో లాంబ్డా స్క్వేర్ ని కామన్ ఫ్యాక్టర్ గా తీసాం, కానీ ఇక్కడ మనం తీయలేము. ఎందుకు, లాంబ్డా అనేది లోపల ఉంది, సైన్ కొసైన్ ఫంక్షన్ లోపల ఉంది కాబట్టి మనం తీయలేం. సో కాబట్టి నౌ వీ కెనాట్ టేక్ ది లాంబ్డా యాజ్ అ కామన్ ఫ్యాక్టర్. సో దేర్ఫోర్ వీ కెనాట్ ఎక్స్ప్రెస్ దిస్ యాజ్, so therefore it cannot be expressed as not equal to lambda power n into f2 of x comma y. So therefore f2 అనేది is not a homogeneous function. f2 जो है ना is not a homogeneous function. ठीक है. So this is an example of an homogeneous function. ये example homogeneous function का example है, ये example non homogeneous function का example है, right? So now let us go for the next definition. When do we say that the given differential equation is said to be homogeneous differential equation? A differential equation dy by dx is equals to f of x comma y is said to be a homogeneous differential equation if the function f of x comma y is said to be a homogeneous function of degree 0. This is important, right? So differential equation dy by dx is equals to f of x comma y homogeneous कब कहलाएगा, कब कहलाएगा, जब ये फंक्शन होमोजीनियस फंक्शन होगा ऑफ डिग्री 0 होगा. होमोजीनियस फंक्शन ऑफ डिग्री 0 जब ये फंक्शन होगा तब ये डिफरेंशियल इक्वेशन होमोजीनियस डिफरेंशियल इक्वेशन कहलाएगा, राइट? సో మనకి ఈ డిఫరెన్షియల్ ఈక్వేషన్ dy by dx is equals to f of x comma y అనేది హోమోజీనియస్ డిఫరెన్షియల్ ఈక్వేషన్ ఎప్పుడు అవుతుంది, ఈ ఫంక్షన్ f of x comma y అనేది హోమోజీనియస్ ఫంక్షన్ ఆఫ్ డిగ్రీ 0 అయితే అప్పుడు ఈ డిఫరెన్షియల్ ఈక్వేషన్ homogeneous differential equation అవుతుంది. homogeneous function of degree 0 అవ్వాలా, అప్పుడే ఇది ఈ differential equation homogeneous differential equation అవుతుంది, right? Is it clear, right? So the differential equation dy by dx is equals to f of x comma y is said to be homogeneous if the function of x comma y is a homogeneous function of degree 0. If this function becomes a homogeneous function of degree 0, then this differential equation is said to be a homogeneous differential equation, right? Now let us discuss about the procedure to solve the homogeneous differential equation. अब हम homogeneous differential equation को solve करने का तरीका के बारे में जानकारी करेंगे, ठीक है? మనం ఇప్పుడు homogeneous differential equation ని solve చేయడానికి procedure steps ఏంటి దాన్ని చూద్దాం. దాని తర్వాత afterwards we are going to do problems. के बाद हम problem करेंगे, దాని తర్వాత మనం problem చేద్దాం, right? So now the given differential equation is of this type: dy by dx is equals to f of x comma y. This is equals to g of y upon x. If the given differential equation is of this type, then what we have to do, we have to go for the substitution method. Put y is equals to vx, ठीक है? अगर हमको दिया गया डिफरेंशियल इक्वेशन इस तरीके का है तो हमको सब्स्टिट्यूशन मेथड करना चाहिए. क्या करना चाहिए, y is equals to vx. మనకి ఇప్పుడు డిఫరెన్షియల్ ఈక్వేషన్ dy by dx is equals to f of x comma y is equals to g of y upon x రూపంలో ఉంటే మనం ఏం చేయాలా, y is equals to vx ని సబ్స్టిట్యూట్ చేయాలా. మనకి ఇచ్చిన ఈక్వేషన్ దిస్ ఇస్ ఈక్వేషన్ నెంబర్ 1 and we have to put y is equals to vx. This is equation number 2. Now what do you have to do? Next step is what we have to do. You have to differentiate the equation number 2 with respect to x. Differentiate the given y is equals to vx with respect to x. Right? So now if we differentiate y with respect to x, it is equals to dy by dx is equals to. Now here you have to use the product rule. So we have two variables v and x. So you have to use the product rule. यहाँ पे जो है ना हम लोग जब differentiate करेंगे यहाँ पे product rule apply करना चाहिए. మనకి ఇక్కడ v అనేది వేరియబుల్ x అనేది వేరియబుల్. సో హియర్ ఇక్కడ మనము product rule ని యూస్ చేయాలా. సో therefore product rule ఏంటి? First variable into derivative of second variable plus second variable into derivative of first variable. Right? Or first function into derivative of second function plus second function into derivative of first function. So therefore dy by dx is equals to first 1 into derivative of x with respect to x is 1. So v into 1 is v plus second into derivative of first. So x into dv upon dx. So here you have to use the product rule. Product rule. What is the product rule? First function into derivative of second function plus second function into derivative of first function. Now this is equation number 3. So now what we have to do? You have to substitute 2 and 3 in 1. మనం ఏం చేయాలి ఇప్పుడు 2 and 3 తీసుకెళ్ళి 1 లో సబ్స్టిట్యూట్ చేయాలా. इक्वेशन नंबर 2 एंड इक्वेशन नंबर 3 को लेके जाके हम लोग 1 में रखना चाहिए. ठीक है. सो dy by dx क्या होगा? फ्रॉम 3 dy by dx is equals to v plus x into dv by dx. dy by dx के बदले में हम लोग v plus x into dv by dx लिखेंगे is equals to g of y upon x. So y upon x क्या होगा? यहाँ से इक्वेशन नंबर 2 से y upon x होगा v. So therefore g of v. Right? Next यहाँ पे फंक्शन ऑफ v है, ये भी v है. So इसको इस तरफ लेके जाएं. So move this v to the other side. So x into dv by dx is equals to g of v minus v. So this is equation number 4. So move the v to the gv side. So it becomes, this is positive. If it goes to the other side, it becomes negative, g of v minus v. Right? Now separation of variables. We have v, gv, v, x, dx. So now we are going to separate the separation of variables. Right? So now therefore dv upon gv minus v is equals to 1 upon x into dx. So now we are going to do separation of variables for the equation number 4, and now we will get like this. So now what we have to do? Now you have to take the integration on both sides. Separation of variables we have done in the previous class, right? So if you have not seen my video, you can go to the previous lecture. So there you can find out I have explained in detail how to solve the differential equations by using variable separable method. So that is what we have done here, right? So integration on both sides, take integration on both sides. So integration of dv upon gv minus v is equals to integration 1 upon x dx plus integration constant. So now this is equation number 5. So now if I find the integration of this one, so then we will get the general solution of equation number 1. So इसका इंटीग्रेशन फाइंड करने के बाद क्या मिलेगा? हमको जनरल सॉल्यूशन मिलेगा, इक्वेशन 1 का जनरल सॉल्यूशन मिलेगा. సో దీని ఇంటిగ్రేషన్ చేసిన తర్వాత మనకి ఏం వస్తుంది? ఈ డిఫరెన్షియల్ ఈక్వేషన్ యొక్క జనరల్ సొల్యూషన్ వస్తుంది. దాని తర్వాత వాట్ వి హావ్ టు డు ఎట్ ద లాస్ట్, వాట్ వి హావ్ టు డు? సో దిస్ జనరల్ సొల్యూషన్ ఇస్ ఇన్ టర్మ్స్ ఆఫ్ v. సో దేర్ఫోర్ వి హావ్ టు రిప్లేస్ ద వాల్యూ ఆఫ్ v. Put v is equals to y upon x. So from here v is equals to y upon x. So v is equals to y upon x सब्स्टिट्यूट करना चाहिए लास्ट स्टेप में हमको. जनरल सॉल्यूशन जो है ना v में आएगा, उसको हम लोग x एंड y में चेंज करना है, उसको v के प्लेस में y upon x सब्स्टिट्यूट करना चाहिए. Then we will get the final solution, right? So this is the procedure to solve the differential equation, homogeneous differential equation of this type. Is it clear? So now what we have discussed, we have discussed about what is a homogeneous function. When do we say that the given function is a homogeneous? Homogeneous function किसको कहते हैं? Homogeneous function देनी अंटामो. Then when do we say that the given differential equation is a homogeneous differential equation? Homogeneous differential equation किसको कहते हैं? Homogeneous differential equation देनी अंटामो, उसके बारे में डिस्कस किया. उसके बाद हमने प्रोसीजर फाइंड किया. So this is the procedure. So now we are going to do the problem, right? Okay, so now we are going to solve the problem. Solve x square plus y square into dx is equals to 2xy dy. So the given differential equation is x square plus y square into dx is equals to 2xy dy. This is 1. So now what happens now? Dy upon dx is equals to dy upon dx is equals to x square plus y square upon 2xy. This is right. So now first of all we have to verify whether this is a homogeneous or not. So therefore dy by dx is equals to dy on dx is equals to f of x comma y, that is equals to x square plus y square on xy, right? So now let us verify whether this function is a homogeneous or not. So f of lambda x comma lambda y is equals to, instead of x lambda x, so therefore lambda x whole square plus lambda y whole square upon 2 into lambda x into lambda y. So this is equals to lambda square x square plus lambda square y square upon 2. So lambda into lambda, lambda square xy. So therefore f of lambda x comma lambda y is equals to, we can take lambda square common, so lambda square into x square plus y square upon lambda square into 2xy. So this is equals to lambda to the power, so 2 minus 2, 2 minus 2 into x square plus y square upon 2x. So this is equals to lambda power 0 into, this is x square plus y square upon 2xy, x square plus y square upon 2xy is what? F of x comma. So therefore this function is a homogeneous function, therefore f of x comma y is a homogeneous function of degree 0, right? ठीक है, तो गिवन डिफरेंशियल इक्वेशन ये है. तो हमने क्या किया, इस फंक्शन, ये है फंक्शन ऑफ एक्स कामा वाई. पहले हमने वेरीफाई किया कि ये फंक्शन होमोजेनियस फंक्शन ऑफ डिग्री 0 है या नहीं है, तभी ये डिफरेंशियल इक्वेशन होमोजेनियस होगा. तो इसलिए हमने इसको एफ ऑफ एक्स कामा वाई लिया. सो यूजिंग द डेफिनेशन हमने लैम्डा एक्स के बदले में लैम्डा एक्स, वाई के बदले में लैम्डा एक्स सब्स्टिट्यूट किया इसमें. सो लैम्डा एक्स होल स्क्वायर प्लस लैम्डा वाई होल स्क्वायर अपॉन 2 लैम्डा एक्स इंस्टेड ऑफ वाई लैम्डा वाई सब्स्टिट्यूट किया. सिंप्लीफाई किया, हमको क्या आया, लैम्डा पावर 0 into f of x comma y. So therefore f of lambda x comma lambda y क्या हुआ, lambda power 0 into f of x comma y. So therefore क्या हो गया, ये फंक्शन is a homogeneous function of degree 0. Therefore अब ये गिवन डिफरेंशियल इक्वेशन क्या होगा, ये होमोजीनियस डिफरेंशियल ఈక్వేషన్. మనం ఏం చేస్తున్నాం ఇక్కడ, dy by dx is equals to x square plus y square upon 2x square రాసుకున్నాము. సో ఇది ఫంక్షన్ ఆఫ్ x, y. సో మనం ఈ డిఫరెన్షియల్ ఈక్వేషన్ హోమోజీనియస్ అని ఎప్పుడు అవుతుంది, ఫస్ట్ వెరిఫై చేయాలి, ఫంక్షన్ అనేది హోమోజీనియస్ అవ్వాలి. కాబట్టి మనం ఈ ఫంక్షన్ హోమోజీనియస్ కాదా అనేది వెరిఫై చేయాలి. సో వెరిఫై చేయడానికి x బదులు లాంబ్డా x సబ్స్టిట్యూట్ చేసినాం, y బదులు లాంబ్డా y సబ్స్టిట్యూట్ చేసినాము. సింప్లిఫై చేస్తే మనకి లాంబ్డా పవర్ 0 ఇంటూ f ఆఫ్ x, y వచ్చింది. సో కాబట్టి ఫంక్షన్ ఏమైంది, హోమోజీనియస్ ఫంక్షన్ ఆఫ్ డిగ్రీ 0. సో దేర్ఫోర్ వాట్ హ్యాపెన్స్, therefore equation 2 is a homogeneous differential equation, right? This is a homogeneous function, homogeneous అయింది కాబట్టి differential equation is a homogeneous. So function is a homogeneous function of degree 0. So therefore this equation number 2 is a homogeneous differential equation, right? Now we have to solve. Okay, so dy by dx is equals to x square plus y square upon 2xy. This is, so what we have to put now, क्या करना चाहिए, ये होमोजेनियस डिफरेंशियल इक्वेशन है, तो इसलिए हम लोग सब्स्टिट्यूट करना चाहिए, put y is equals to v into x. సో ఇది హోమోజీనియస్ డిఫరెన్షియల్ ఈక్వేషన్ అయింది కాబట్టి మనం ఏం సబ్స్టిట్యూట్ చేయాలా, y is equals to vx అనేది సబ్స్టిట్యూట్ చేయాలి. సో నౌ వాట్ వీ హావ్ టు డూ, differentiate 3 with respect to x. हमको क्या करना चाहिए, सब्स्टिट्यूट करना चाहिए y is equals to vx और उसके बाद उसको डिफरेंशिएट करना चाहिए. మనం y is equals to vx సబ్స్టిట్యూట్ చేయాలా, దాని తర్వాత దాన్ని డిఫరెన్షియేట్ చేయాలా. ఏమవుతుంది అప్పుడు, సో therefore dy upon dx, so here we have to use the product rule, इधर product rule अप्लाई करना चाहिए. So v into d by dx of x plus x into dv upon dx, right? So therefore dy upon dx is equals to v into d by dx of x is 1. So v into 1 is v. So d by dx of x होगा 1. So v into 1 होगा v plus x into dv upon dx. So this is equation number 4, right? So dy by dx differentiate చేస్తే ఏమైంది, product rule apply చేయాలా. So dy by dx is equals to v plus x into dy by dx వచ్చింది, right? So now what we have to do, put 3 and 4 in 2, right? So we have to substitute equation number 3 and equation number 4 in 2. So therefore what happens, instead of dy by dx we'll write on this one. So therefore v plus x into dv upon dx is equals to, so x square as it is, instead of x square, instead of y we have to put vx. So हम लोग x square के बदले में x square लिखेंगे प्लस इंस्टेड ऑफ y vx रखना चाहिए, इंस्टेड ऑफ y vx. So vx square upon 2x instead of y vx. రైట్. సో మనం ఏం చేయాలా, 3ని 4ని తీసుకెళ్ళి 2లో సబ్స్టిట్యూట్ చేయాలా. సో dy/dx వాల్యూ v ప్లస్ ఎక్స్ ఇంటూ dy/dx రాసుకున్నాం. ఎక్స్ స్క్వేర్ బదులు ఎక్స్ స్క్వేర్ రాసినాము, ప్లస్ బదులు ప్లస్ రాసినాము. y బదులు vx సబ్స్టిట్యూట్ చేయాలి. సో vx హోల్ స్క్వేర్ అపాన్ 2x అలాగే రాసుకుంటాము. ఇన్స్టెడ్ ఆఫ్ y vx సబ్స్టిట్యూట్ చేస్తాం. నౌ వీ హ్యావ్ టు సింప్లిఫై. సో దేర్ ఫోర్ v ప్లస్ ఎక్స్ ఇంటూ dv upon dx is equals to x square plus v square x square, right? Vx whole square means v square x square upon x into x, 2x square v, right? So x into x becomes x square, 2x square v. So now we can take out x square as common factor from the numerator. So x square we can take the common factor. x square को हम लोग common निकाल सकते हैं. x square ही మనం common factor తీయొచ్చు. 1 plus v square upon 2x square, right? So then we can cancel this x square from the numerator and x square from the denominator. We can cancel it. So therefore v plus x into dv upon dx is equals to, so x square is cancelled from the numerator and denominator, 1 plus v square upon 2v, 1 plus v square upon 2v. Next, these are the v terms. Here v is there, move this v to the other side. So therefore x into dv upon dx is equals to 1 plus v square upon 2v minus v, right? Now we have to simplify this one. So x dv upon dx is equals to 1 plus v square upon 2v minus v upon 1. So therefore x into dv upon dx is equals to, take the LCM, 1 plus v square minus 2v square upon 2v, right? So take the LCM, 2v, 1 plus v square minus 2v square upon 2v. So therefore x into dv upon dx is equals to 1 plus v square minus 2v square is 1 plus 1 minus v square upon 2v. So now here v terms are there, dv is there, x terms and dx is there. So what we have to do? Separation of, now separation of variables. separation of variables, separation of variables. So therefore 2v upon 1 minus v square dv is equals to 1 upon x dx. So now what we have to do, take integration on both sides. ठीक है, हमने इसको सिंप्लीफाई किया, यहाँ पे जो है ना v वेरिएबल x वेरिएबल्स है, dx है, v है, dv है टर्म्स. सो हम लोग जो है ना सेपरेशन ऑफ वेरिएबल्स करना चाहिए, v और dv, x और dx अलग अलग लिखना चाहिए. మనం ఇక్కడ సెపరేషన్ ఆఫ్ వేరియబుల్స్ అప్లై చేసినాము. అప్లై చేసిన తర్వాత what we have to do, take the integration on both sides. So therefore integration of 2v upon 1 minus v square dv is equals to integration of 1 by x dx, right? So now here we are going to adjust and we are going to use the formula. Now if you see the derivative of the denominator, so the derivative of denominator, derivative of 1 is 0 and derivative of minus v square is minus 2v. Here we have 2v. So now I am going to adjust that one. So what we'll do is minus 2v upon 1 minus v square dx is equals to integration of 1 upon x, right? So therefore now this is derivative of denominator is in the numerator, integration of f dash of x upon f of x dx, integration of f dash of x upon f of x dx. So denominator's derivative is in the numerator, so then we have log f of x, log denominator, right? So here derivative of this one is 1 minus v square is minus 2v, so it is present in the numerator, so we will use this formula. So डिनोमिनेटर का डेरिवेटिव न्यूमरेटर में है, तो इस ఫార్ములా గా యూస్ करेंगे हम लोग. డినోమినేటర్ యొక్క డెరివేటివ్ న్యూమరేటర్ లో ఉంది కాబట్టి ఈ ఫార్ములాని యూస్ చేస్తాము. ఇంటిగ్రేషన్ ఆఫ్ f dash of x upon f of x dx is equals to log f of x. So therefore minus log 1 minus v square is equals to integration of 1 upon x log x plus log c integration constant, right? Okay, so now simplifying this one, so this can be written as log of 1 minus v square the power minus 1 is equals to log a plus log b, so that is equals to log xc. So this can be written as log of 1 upon 1 minus is equals to log x c. So this can be written as 1 upon 1 minus v square is equals to x c, or x c is equals to 1 upon x c. So instead of v, what we have to do, we have to put y upon x. So therefore 1 upon 1 minus is equals to x. So therefore 1 upon 1 minus y square upon x square is equals to xc. So this, if we simplify this one, so 1 upon x square minus y square upon x square is equals to xc. So it goes to the numerator. Therefore x square upon x square minus y square is equals to xc. So moving x on both sides, so x upon x square minus y square is equals to c is the general solution of given differential equation, right? So this is the general solution of the given differential equation. So now we have come to the end of our class. Uh, if you like my video, kindly hit the like button and as well as subscribe to my channel for watching more videos. Thank you.